Welcome back to the Solutions Manual. In this video, we will solve the problem F3-8 from RC Hibbeler Engineering Statics 12th edition. According to this problem, we have to determine the tension developed in cables AB, AC and AD. Now to solve this problem, first of all, we have to draw the free body diagram. So we have a force in the cable AD. We have a force in the cable AC. We have a force in the cable AB. Let's label them. So this right here is TAD. This is TAC. And this is TAB. Now we have to resolve the TAD force and the TAC force into its components. For TAD force, we have a component in the negative y-axis and in the z-axis. For TAC force, we have a component in the y-axis and in the negative x-axis. Let's label them. So the vertical component of TAD force is TAD and the ratio of opposite, which is 4, over hypotenuse, which is 5. And the horizontal component is TAD into the ratio of adjacent, which is 3 over 5. Similarly, for TAC force, this component of TAC force is TAC and the ratio of 3 over 5. And the Y component is TAC and the ratio of 4 over 5. So this is our free body diagram. Now we have to express each of the forces in terms of Cartesian vector form. So starting with the TAB force. So TAB force has a single component directed along the positive x-axis. So we just have TABI plus 0J plus 0K. For TAD, we have no component along the x-axis, so 0I. We have a component in the negative y-axis, so negative 3 upon 5 into TAD, J, plus, and we have a component in the positive z-axis, so 4 upon 5 into TAD, K. So upon simplification, we have 0I minus 0.6 TAD, J plus 0.8 TADK. Now for TAC force, we have a component along the negative x-axis, so negative TAC and the ratio of 3 upon 5 I. We have a component along the positive y-axis, so TAC into 4 upon 5 J plus 0K. Negative 0.6 TAC I plus 0.8 TAC J plus 0K. We also have to express this weight force in terms of Cartesian vector form. The weight is acting in the negative z-axis, so 0I plus 0J minus 900K. So far we have expressed our forces in terms of Cartesian vector form. We know that the resultant force is the vector sum of all these forces. So TAB plus TAD force plus TAC force plus the weight force. And for equilibrium, the resultant force should be 0. So 0I plus 0J plus 0K. Let's call this equation A. So now we are going to substitute the Cartesian vector form of each force into the equation A. So equation A would become from TAB force vector, we just have a component in the x-axis, so TABI, plus from TAD force vector, we have the components in negative y-axis and in the positive z-axis. From the TAC force vector, we have the components in the negative x-axis and in the positive y-axis. From the weight force, we just have a component in the negative z-axis, so negative 900 K equals to 0I plus 0J plus 0K. So now we have to compare the I, J and the K components. So comparing I components, so we have TAB minus 0.6 TAC equals to 0. Let's call this equation 1. Now comparing the J components, we have negative 0.6 TAD plus 0.8 TAC equals to 0. Let's call this equation 2. Now comparing the K components, so we have 0.8 TAD minus 900 equals to 0. So from here TAD comes out to be 1125 lbs. So this is our first answer. Now we have to substitute the value of TAD into the equation 2. The equation 2 becomes negative 0.6 TAD, and TAD is 1125 plus 0.8 TAC equals to 0. So from here TAC comes out to be 843.75 lbs. This is our second answer. And now we have to substitute the value of TAC into equation 1. The equation 1 becomes TAB minus 0.6 into TAC, and TAC is 843.75 lbs equals to 0. So from here TAB comes out to be 506.25 lbs. So this is our third answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.